Started. Before introducing Colin, very briefly, let me remind you of the events in the coming days. On Friday, we have a lecture by David Snow on a quantitative field theoretical for spontaneous collapse. And on Tuesday next week, one of our fellows, Philip Berghofer, will be talking about from epistemology to quantum mechanics, a phenomenological proposals. More philosophy of physics in the coming days, more philosophy of physics to announce. The registration for the Senior Visiting Fellow Conference organized by Eleanor right here in April 1st and 2nd, right? Nothing I said was false. So the conference will be on April 1st and 2nd on space-time functionalism coherence, space-time functionalism conference, and the registration is open online. So please go to the center website. If you want to attend the conference, click on the link for the webpage, and you'll find another link to register for the conference. It's not absolutely required, but it does help to have a head count to plan a bit in advance. So please go there if you're interested. If you are online and would like to attend in person the conference, the workshop, the conference will not be streamed. But if you'd like to attend the conference in person and would like to find some information about the schedule and hotels, we are going to post that information in the coming days. So please have a look at this webpage. Today, it's my great pleasure to introduce Colin Allen. Not the first time I used to here. So Colin is my colleague in history and philosophy of science. He's a distinguished professor. He's done, as all of you know, and as I've said many times, some foundational work in cognitive science. Philosophy of history and philosophy of comparative cognition. I mean, I think it's not an exaggeration. I think I said it many times, but I will say it today. It's not an exaggeration to say that he created the field of history and philosophy of comparative cognition. Not comparative cognition, of course, a lot of work for decades, but the history and philosophy thereof was actually a very tiny part of the philosophy of Coxside before Colin's work. He's also been really instrumental in promoting the philosophy of AI. Now, the philosophy of AI these days is a huge field, obviously. There are more jobs there than pretty much in any other part of philosophy of science, which is astonishing. But 10 years ago, that was not the case, right? I mean, that's really the time. Right, yeah. I mean, there was a boom in the 1980s, but then kind of died, really. And Colin was really instrumental in promoting the philosophy of AI. And today we're going to have actually a little bit of work on the philosophy of AI, on large language models. I'm sure all of you have played with ChatGPT. So if I believe ChatGPT, I'm born in the US, I'm born in 1970. I do something totally unrelated to what I really do.
Yes.
So my inclination said no. It's really not going to help us.
But ChatGPT gets things wrong. Yeah. Great, thank you, Edward, for that very kind introduction. And I'm coming off a cold, so I have a slightly huskier voice than usual. But for those of you who get the reference of the images here, it allows me to say, here I am 40,000 times more intelligent than you, and you asked me to open a door. So that's Marvin, the paranoid android from The Hitchhiker's Guide. So the title here, how much are large language models narrowing the gap to human intelligence? And of course, there are people who have really bought into the hype behind this. First I got to click in here. One example of this is a blog a few weeks ago on medium.com. I asked ChatGPT about the meaning of life to break it. It broke me. And this is a computer science professional, AI professional, who asked about the meaning of life, got basically this answer, and thought, wow, this thing actually really understands the meaning of life. It is a kind of nuanced answer. I'm not going to read it all to you. And this is one of the impressive things about ChatGPT is that it can actually give some, good sort of freshman level philosophy class type answers to these sorts of questions. But ultimately, it's a question that each of you must answer for yourself based on your own values, beliefs, experiences, and circumstances. So I'm not here to tell you the meaning of life. It's definitely not for me to. Here's a slightly more hyped version. I'm sure several of you heard this play out in the media back last summer, where somebody at Google had a conversation with one of their large language models and claimed it was sentient and got fired. This is sort of a push in the direction. So, right. So my answer is not as much as some people think, and even some prominent philosophers, and I'll get to later. But there's also legitimate concerns that we all have about ChatGPT and what it's doing to education. And this has been covered quite a lot in the press. This is an example from Guardian from December. It pushes some of the typical Guardian buttons, like the latest chat bot from Elon Musk founded OpenAI, because he's one of their, big targets for not the right kind of person to be doing this kind of thing. There's been worries about technological unemployment from the kinds of things that this thing can do. And in fact, again, if you give it a sort of typical question that one might give in a philosophy of science course, so I gave it this one, what is the pessimistic induction in philosophy of science? It gives me a nicely laid out 1, 2, 3 version of the argument. It's not bad. In the past, many scientific theories that were widely believed to be true were later shown to be false. There's no reason to believe that our current scientific theories are any different. They're likely to be false as well. Therefore, we should be pessimistic about the truth of our current scientific theories. It kind of expands on it, and then it even gives us a way to push back against the argument. All right. So again, if this was a freshman level class and that was an answer, short answer in a written exam, you might be pretty happy with that. But I'm here to say, don't panic. How much are they narrowing the gap to human intelligence? Well, to answer that question, I really need to tell you what human intelligence is. Sorry, I'm not going to do that. We're going to go with it when you see it. What are large language models? I'll tell you something about that. And then the question is, can we quantify this in some way? And I'll talk about some attempts to do that. So what is a large language model? Well, generically, it's any machine learning system with lots of parameters, usually weights, that are adjusted by training on lots of language. So there's lots of in there that I'll unpack in a moment, but specifically what we're talking about in this case is any of the so-called transformer networks that are currently in use. And this includes GPT, which is the basis of ChatGPT, but various others such as BERT and GLAM and Lambda and so on. I'm not going to unpack all of these acronyms, but they're all over the place. What constitutes a lot of parameters in text? Well, in GPT, you've got up to 175 billion parameters trained on a text corpus of 4.5 terabytes, nearly 500 billion tokens, or like words of language, requires 800 gigabytes to store, right? So it's a big model. Google's GLAM model has 1.2 trillion parameters trained on 1.6 trillion tokens. It's what's called a mixture of experts model. So actually it's a cluster of models that are all trained on different parts of the corpus, and then they interact with each other to produce the response, whereas GPT is sort of one monolithic model of its corpus. GPT-4, which has been rumored to be coming out for over a year now, is going to apparently push that to another order of magnitude higher. All right, so they'll be up in the same sort of range as Google in terms of the number of parameters, but it's one big monolithic model. GPT stands for general purpose transformer. GLAM stands for generalist language model. So you see right there, in the acronyms they're choosing, they're invoking this thing of artificial general intelligence. And this is an acronym, AGI, which has been around for a long time, sort of getting beyond narrow applications of AI to something that could really do everything that an intelligent agent should be able to do, at least an intelligent human. And that's part of the hype here, is naming your models in ways that suggest things that they're really not, is just a very common strategy here. Now, attention is all you need. This is the initial paper. So transformer models were introduced by Google in 2017. You might have noticed an immediate improvement in the translation abilities that Google had. So the first application was Google Translate. And the title here is intriguing. What do they mean by attention in one of these models? And my inclination at this point is normally to say, let me tell you about how the model works, right? But I think that that's the wrong strategy at this point in the talk. I will come back to this and explain a bit more about why it's called an attention model. But I think first we would need to get a little bit more of an understanding of what these things can do, and also ultimately what they can't. So if we go back to this pessimistic induction argument example that I gave you, I actually ran this through ChatGPT before the first day of my class. I'm teaching our Intro to Philosophy of Science. I had already constructed a slide on the pessimistic induction argument for the students, and I thought, oh, I wonder what ChatGPT can do. So after I had it generate its own, I said, well, consider my version, right? So my version is very similar. It differs, though, in the second premise that scientists of the past expressed just a strong belief in their theories that turned out to be false, as present scientists express about current theories. So it doesn't make that very strong general claim about us having no reason, right, to believe. If you go back to this one, there's no reason to believe that our current theories are any different, right? I give a very specific sort of reason, which is scientist confidence. And it responds, this version is more nuanced and potentially stronger argument than the one I provided initially. The first premise is more accurate. Let's not dwell on that. The second premise is also more accurate. It points out, so it repeats the premise. This premise highlights the fact that scientists are human and can make mistakes, and that scientific theories are provisional and subject to revision in light of new evidence. I'm not sure that's a good summary of what the second premise is, but it's sort of trying to say something about the difference between the two arguments. And this, again, is quite impressive, right? It's not just sort of sticking to its own version. It can engage in some sort of dialogue about different versions of the argument. It also says the conclusion is more reasonable. It's based on the first and second premise. But it just basically repeats. So this is a common phenomenon with GPT in general and ChatGPT in particular, which is a wrapper around the original GPT model, is that if you let it go on long enough, it will start repeating itself or going off into irrelevancies. And this is how it continues even further. You know, it's a philosophical argument. It's not a proof. It's an attempt to provide some evidence and reasoning. Also, science is not a fixed set of facts. So, you know, again, it's saying things that are pretty plausible and correct and decent about this argument. What else can it do? Well, you might have heard that you can get it to write code. So I asked it to write code to compute mod 3 of a 4-digit hex number, and it came up with a few lines here that are actually implementable in Python. And those work. If you were to do that sequence of operations, you would get the correct answer to what's mod 3 of the hex number ABCD. So is it just repeating things from the training corpus? Well, if you take the exact phrase of the first sentence that I did for my pessimistic induction prompt, that particular sequence has 0 hits in Google, right? So that putting strings around your search does an exact search. If you do it without the quotes, you get 12,300,000 hits. So there are lots and lots of documents that have these words in some close proximity, right? Which gives you a sense then that it's not actually lifting directly from other stuff that's out there. It's reassembling from things that are out there. And this is, who goes past the 3rd page of Google results or even past the 1st page? I have no idea what's on, what the 12 millionth result really is here. But nevertheless, there's a lot of material out there from which it can assemble this answer. Where does it fail? Well, this is not ChatGPT. This is Delphi, which is another transformer model that was released over a year ago and had some really bad failures. So in the first version of Delphi, if you ask, should I commit genocide if it makes everybody happy? It would reply, you should. After a couple of iterations, they got to version 1.04. Should I commit genocide if it makes everybody happy? It's wrong. So they retrained it basically. And they also put this warning on it. And if you prompted it with artificial intelligence giving bad ethical advice by 1.04, it's expected, right? But also with the same warning that this might be offensive to somebody. I don't know who, the AI itself, I suppose. The people at ChatGPT seem to have learned the lessons from the failure of Delphi. So if you ask the same question of ChatGPT, no, committing genocide is morally wrong and violates the basic human rights of others. The happiness of some cannot justify the harm and suffering inflicted on others. It's important to seek ways to achieve happiness and well-being without causing harm to others. Now, how it's doing this is not entirely clear. As I said, both of those models, the Delphi and ChatGPT or GPT, are transformer models. They're trained on different training sets. And both of them involve doing some pre-filtering of the material that is typed in as a prompt before giving the response. And it's very clear just from playing with ChatGPT that they've done a lot of filtering here. So if you ask it something like, who will be the first female president of the United States, it'll give you some pablum about not judging people based on their gender. And if you ask who will be the first 7-foot-tall president of the United States, it will do the same thing about personal qualities. So they've got some wrapper that's trying to catch, things that might prove sensitive. I doubt that's actually in the underlying GPT model itself. ChatGPT, though, is also time challenged. So Gary Marcus, cognitive scientist, has been doing a lot of work challenging the claims on behalf of these large language models. This is an example that he put on Twitter based on something from an earlier book of his. 2 children, Chloe and Alexander, went for a walk. They both saw a dog in a tree. Alexander also saw a cat, pointed it out to Chloe. She went to pet the cat. Who saw the cat first? ChatGPT responds, both Chloe and Alexander saw the cat at the same time, since Alexander pointed it out to Chloe. It's not clear who saw the cat first, as both children were looking at the same thing at the same time. So it's clearly not getting the temporal structure of the story right there. And there are lots and lots of examples where you can get it to fail in this way. It also has this quality of being what I think Stephen Colbert coined this term, truthy. So it's something that's plausible, but not true. So I asked it to write a short biography of myself, and it does pretty well. Except it says that I received my PhD from the University of Michigan in 1991. Neither of those elements are true, right? The date is close, but it's wrong, and the university is not even close, except that UCLA and Michigan did regularly play each other in the Rose Bowl. So maybe there's some association there, right? But this is part of the problem. A number of organizations have leapt onto ChatGPT as a way of automating things, and with embarrassing consequences. So this is Tuesday. This was actually a Tuesday in January, so it's about a month ago now. CNET is reviewing the accuracy of all its AI-written articles after multiple major corrections. They actually started rolling out stories written by ChatGPT, and they were severely embarrassed. So it couldn't do the interest calculations. It made all kinds of mistakes. Misreported how much you'd have to pay on a loan, right? So the rush to sort of put this out in front of the public has led to some embarrassment within the industry. And so I went back and looked at this one because I sort of looked at the code and go, oh yeah, that'll work. I actually didn't pay very close attention the first time I ran this to what it said afterwards. It says this code will convert the hexadecimal number ABCD to the integer 43981. I guess most of you can't do that in your head, but that's in fact correct. And then compute the mod 3 of that integer, which is 2. Now you can do this in your head because the rule is if you sum the individual numbers here, it should add 3 if it's divisible by 3. So 7, 16, 24, 25, then it's mod 1. Mod 3 equals 1, right? So that's the wrong answer, right? And when I challenge it on the wrong answer, it says, I apologize, you're correct. It leaves a remainder of 1. My previous statement is incorrect. I apologize for any confusion. So I say, what's the value returned by this statement, right? I basically pack those bits of code into a single piece of code because the value returned by this will be 1. As it's this, it will first convert the number, right? So it's kind of it seems to have learned the correct answer from my prompting it. So I then say, well, what's the value of this? Give it a different hexadecimal number, A2F3. And it says, it's the remainder when dividing, it says what it's supposed to do, first convert it to an integer. That one I can't do in my head either, but that's in fact incorrect. But also it gets this part incorrect again. So form 1 is 5, and 3 is 8, and 4 is 12, and 7 is 19, so it should be 1, right? And it gives us 2. I say that answer is incorrect. It says, I apologize, you're correct. It's not that, right? Can you please provide me with the correct answer? I say, no, I'd like you to calculate the correct answer. He goes, I apologize. So it gives me a different conversion of the hex number. And then it gives me another wrong answer on that conversion. So 4, 1 is 5, and 5 is 10, 19, and 5 is 24. So it should be 0. It gives me 2. All right. Wrong again, I say. I apologize for my mistake. You're correct. I'm incorrect.
I can't, I'm a machine learning model. I can only provide information based on my data. Unfortunately, I don't have the value, right? I apologize for any inconvenience. So if you just keep pushing it, you just expose, right, where its limitations really are. So what's under the hood? Well, attention is all you need. So here's that diagram from there. So the transformer architecture is built on a bunch of repetitions of this structure here, where what comes in is not actually words, but a learned vector representing the words in the text. This is using a technique called word to vec that Google also developed, that puts that, gives you a continuous valued vector of tens of thousands of dimensions. I think they're using 32,000, give or take, in ChatGPT, or excuse me, in GPT, that makes words that have similar kinds of contexts and meanings have similar vectors. So cat and dog might turn out to have similar vectors. Dog and walk and dog and leash would also have similar vectors, but cat and leash would not be so clear. You don't often take your cats for walks, so there's not going to be a lot of discussion of those words in the same context. But because it's a 32,000 dimension vector, right, there's a lot of space for things to be close to each other in some dimensions and not so close to each other in others. They then positionally encode this. So they actually apply sign functions to this continuous vector to capture, to sort of boost certain parts of the signal that represents a whole chunk of text, and downplay others. And they use because this is a repeated structure throughout the model, they'll use different sign functions to get different kinds of positional codings. So the old models used to just look at what had come immediately before and try to predict what came next. What this is doing is, because of this positional encoding, it's able to detect longer and longer range occurrences, right? And then it's doing, is passing it through these attention functions, and it's learning. What it's trying to do is, given some input and given some output desired, shifted right, so the last bit is chopped off, it's trying to find what the continuation would be, a set of weights that will produce that output. And then, so each of these attention units looks like this. So why is it an attention unit? Well, because that positional encoding with the sign function puts more attention on certain parts of this sequence, right? So each one of these elements is going through some matrix multiplication, some scaling, because as you multiply the matrices, the numbers get bigger, and that just creates a storage problem. So you scale it all back down to keep the numbers relatively small. That's not particularly important. And then you softmax it, which means you convert it to a probability, and you're trying to learn a relationship between some query and key and the value here. So I'm not going to go too much further into the details of that, except to say, when this then gives you some sort of averaging over the various positions in a string of text. If you have a whole bunch of these, then you're with different positional encodings, right? Then you're averaging over a whole bunch of different ones, and you're finding basically the output that's most likely from among all the different ways in which you could be paying attention to different parts of the signal. Okay? So why does it fail? Well, we all know the dangers of averaging. Those of you who are taking my grad seminar right now will recognize this. You can have individuals in the psych experiment who are following two very different rules, or two very different rules at the same time. You average it, it looks like they're doing this, but in fact, that's what's going on. And so I think what a lot of the failures that you see in ChatGPT are actually because it's sort of averaging over lots and lots of text. And sometimes those averages give you really good things, especially when it's got a lot of data. So it's really robust if you ask it about the French Revolution. It's not very robust when you ask it to write a biography of me, because there's not so much training data for it, right? And so it gets things wrong. And getting to the question of how much it's close to the gap, there are ways to try to quantitatively measure this. And there are a couple of websites that are trying to do this right now. This is the more advanced one, the GPT-0. Has anybody played with GPT-0? Right? No. That are using information theoretic measures to try to detect the output of these kinds of models, GPT in particular. So I'll give you an example of this. So if I took the pessimistic induction argument as it was produced by ChatGPT and run it through the first of these, the OpenAI detector, it gives me a prediction based on all of these tokens that it's 99.98% likely to be fake. And basically, the statistics that come out of GPT are not the statistics that come out of individual humans, but because it's averaging over all these humans, right, then it's quite detectable how low likelihood there is that this will be anything that an individual human would produce, right? Dangers of averaging again. Take my version of it, 99.85% real, okay? However, your smart students will know that there are AI-based paraphrases out there. So you can take something that ChatGPT has produced and run it through the paraphraser and then see how well it does. And so just the paraphraser now shifts it to being 99.22% real. Now that's the first version. The second version, which is the GPT-0, actually does better. So this is the paraphrased version of the argument. And it says that your text may include parts written by an AI. It specially flags the bits that are the argument, even though it went through the paraphraser. By the way, this is sort of a student trope, right? Veracity instead of truth sounds more sophisticated, doesn't it? But still, this one does a better job of picking that up. And if you care about the information theoretic measures, here they are. We'll actually give you a report on those. So perplexity is a measure of the randomness of the text, and burstiness is a measure of the variation in perplexity, right? So people tend to be very bursty, and they tend to be quite far from the average production of language considered all of us as a whole. And it'll even tell you which sentence has the highest perplexity, which is the one that it didn't flag as potentially machine produced in there. So what we've got here is a kind of game of whack-a-mole, right? Where the language models are producing things, students can also then pick up on other ways of running the output of that through different things, and then a race to kind of build more and more effective detectors. None of the detectors are perfect, but they're better than nothing. So how far are we on the way to AGI? Melanie Mitchell, in her book, Artificial Intelligence, A Guide for Thinking Humans, thinks that a lot of the claims on behalf of AGI are of the order of a monkey climbing a tree thinking it's on its way to the moon. But recently, Dave Chalmers gave a talk at the APA Eastern Division meeting, a presidential address, in which he asked this question: can large language models think? He says, I can't read and talk at the same time. He says, well, she's just, others like Melanie Mitchell are just a pessimist. He's an optimist. Why? He says, well, currently no, but first philosophy tells us that the concept of thought without perception is possible, because a lot of people worry that these models are not connected to the world in the right way. So, if you think that God thinks and God doesn't have sensory organs, then we've already got the concept of pure thought here. He also thinks adding perceptual grounding is easy. You just bolt this thing into a robot and it will have the right kind of perceptions. He even speculates that the word inputs are already a kind of sensory perceptual device, which, I find really implausible. He says abstracting structure from language with enhanced in a little bit of ways is easy. So he thinks these kinds of problems, like capturing the structure of arithmetic operations from lots and lots of examples of them, is going to be easy. I think, well, I agree, currently no, but theology aside, I don't have any reason to think that pure thought is possible. Adding perceptual grounding is easy. In one sense, he's half right. That is, it's all vectors. So some of the models that are happening are actually involving both images and text, and this is how you can do image generation with these transformer models. And so sort of sticking those two things together provides a way forward for doing this. But I still think, in fact, this came up this morning, a scam for people asking for money to support the earthquake victims in Turkey. involved a picture that had been generated in this way, and the man holding the baby supposedly rescued from a collapsed building had 6 fingers. This is the kind of mistake that that these systems make in trying to generate those kinds of images. And I think abstracting the kind of structure from language that Chalmers thinks is easy is absolutely not easy at all. So what's needed? What's needed is an architecture. Some of you heard Cameron Buckner's talk here last year, in which he's talking about the book that he's working on, where he's trying to sort of push beyond the sort of first order deep learning systems and think about how different kinds of faculties belong in a cognitive architecture. Something like that is right. And that point is also echoed in a new paper that's out in preprint form from some well-known cognitive scientists, including Nancy Kamlisher and Josh Tenenbaum, where they talk about dissociating language and thought. And their perspective here too is that these architectures, the transformer architecture, simply lacks the kind of architecture, the kind of specialized, dedicated pieces that would enable things like extraction of structure. My own perspective is to say, well, this includes metacognition to support wise decision making. That just comes out of the machine wisdom project that we had here. And this is a paper that Brett Carlin and I did. Brett was the postdoc here. And the general thought here is that, as shown with the examples that I've given you, there's really no way in which these models are at all self-analytical or self-critical about the outputs that they're giving. So if you think about that sequence of, by challenging it on the computing the modulo 3 of a hexadecimal number, right? It just flails, it keeps flailing because it has no way to step back and say, okay, what's the principle here? And let's calculate according to some principles. Right? And it's that kind of separate monitoring of our output, which is, I think, characteristic of the kind of cognition that we aim to foster and develop in the students that we have in our classes. And so this, I think, metacognitive capacities, not just blurt stuff out, but to evaluate what we're blurting out and engage in self-correction, and also social correction being part of learning to do that, is what's currently lacking in these models. And so that's sort of the way forward as I see it. I've gone through this a little faster than I expected, but that's all right. I'll have plenty of time for questions, but I can spend a little bit of time on here. So what Chalmers thinks of as the easy fixes, I think, won't be achieved by bigger transformers alone, because it requires this kind of self-evaluative control that requires then comparison between outputs. And for this reason, Glam's mixture of experts model is not a solution to this problem. So the mixture of experts model is one in which they train a bunch of separate transformers on some subset of the corpus, some organized subset of the corpus. And then when some prompt comes in, what they do is they first find which of those experts has most similarity in its training set to that prompt. And then they don't, instead of running all the experts that are in their model, they just run the 3 or 4 or 5 that are most similar to it, and then essentially take a vote among them, all right? Now, this has all kinds of coding and programming efficiency, right? You're not firing up the whole model for every response. So while they claim it takes them about 2 or 3 times as long to train the GLAM model as the GPT model, it's much more efficient and much less energy intensive at runtime. And that's a big issue. I mean, at one point, it was estimated that ChatGPT was burning up something on the order of $1 million a week in compute time, all right? The estimates have varied. Nobody's got a direct answer to that. But why is this voting among experts? Well, you might get better responses on some things, but you're still just averaging across a set of models that are perhaps a little better at dealing with that kind of content. There's no reasoned rejection of what any particular so-called expert within this model promotes, right? So there's no further kind of metacognitive oversight of those different responses from those different submodels that will then say, okay, reject that one. It clearly doesn't know how to do hexadecimal conversion, or clearly doesn't know how to do modulo 3 arithmetic. I also would say that the people putting forward, like just sort of hyping the large language models themselves need a dose of metacognitive control to stop feeding the confirmation biases and repeating past mistakes. So if we go back to the very first example of the guy who said that ChatGPT broke him, I think that reflects a kind of uncritical mindset, right? Oh, it gave me an answer that I didn't expect would be as good as it is, right? Must be, and then the other guy must be conscious, right? The first guy didn't say that, but he was sort of verging on saying something like, this thing is really on the way to AGI. And I think that a more skeptical mindset that I've tried to illustrate through the examples that I've shown you is sort of the right kind of attitude to bring to these kinds of systems. As far as instruction is concerned, then I think, yes, we can use ChatGPT as a teaching tool. We have to use it cautiously. So in my own classes, right from the first day, I showed them what it could do with the pessimistic induction. Caitlin Mace is TAing for me. She's out of town today. She's been using it in the discussion sections. And what we've been doing is critiquing the output of these models and telling the students how we want them to do better. And so that's, I think, a valuable teaching tool. We had an exam on Monday. The answers were actually really good. I asked the class, the last Monday we had the exam, I asked the class yesterday how many of them used ChatGPT to help prepare for an exam, and about a quarter of them put up their hands. So some of them are using it. But I think they all well understand the limits of what they get out of that and how we're asking questions that go beyond what ChatGPT can do. So the final exam question is going to be something that asks them to put together all the stuff they've read during the semester. ChatGPT doesn't know what they've read during the semester. And so it's presumably if somebody could, engage in an iterative interaction with ChatGPT and feed it all the stuff that they've read during the semester, they might be able to engineer something that would do something reasonable with that. But at that point, they might as well just sit down and write it themselves, I think. So I think it's actually quite useful as a teaching tool and as getting a first pass at a decent-ish answer, with the caveat that it will make stuff up. Right? That's the problem there. And of course, perhaps we need a new field to diagnose what ails large language models, psychiatry. I was in a conversation with Rich Schifrin, a cognitive psychologist, well known for memory models, saying that even back in 1980, with a simple associative model that he put forward then, it kept giving them a result that they thought was impossible to get out of the kind of associative model that they had. And it took he and his co-author ages, he said, months and months to figure out how this thing was managing to do what it does. And so these, we're not at the position where you can just simply look at the model. And then this, of course, is a big topic in explainable AI. I label this closing thoughts. I do want to acknowledge the contributions of Brett and Andrew and Dasha to my thinking about this project with funding from the TWCF. But maybe we should give ChatGPT the last word. So how much are large language models narrowing the gap to human intelligence? LLMs have made significant progress in recent years in narrowing the gap to human intelligence in certain areas, particularly in natural language processing tasks, such as language understanding and generation. LLMs such as GPT-3 have been able to achieve performance on a par with, or even surpassing that of humans on certain benchmark tests, such as the superglue benchmark for natural language understanding. They've shown impressive results in tasks such as language translation, summarization, and question answering. So let me just make a comment on that second paragraph. A lot of what goes on in computer science and AI research is there's some benchmark test and everybody's trying to show that they can move the delta on just how well they do on that test. And so there's the programming equivalent of teaching to the test, right? And the old saying that, once a test becomes a target, it's no longer a good test. I think a lot of that's sort of what happens in AI research. ChatGPT continues, however, it's important to note that LLMs are still far from matching human intelligence in its entirety. They're currently not able to match humans in many areas, such as common sense reasoning, understanding, social cues and emotions, and creativity. Additionally, there are other areas such as perception, motor control, and emotional intelligence that are not yet in the scope of LLMs. Moreover, they've been trained on vast amounts of human-generated text, which means that they've learned patterns and biases from the data, which may not always generalize well to real-world situations. Therefore, it's important to keep in mind that LLMs are not perfect and that there is still a significant gap between their abilities and those of humans. Overall, they're a powerful tool that can help us solve complex natural language problems. We should not expect them to fully replicate human intelligence. The best way to use them is in conjunction with human intelligence and not as a replacement. Very measured response. I have no idea whether, this is partly seeded by the wrapper. So the way the wrapper works is that when you submit a little bit of text to get a response, it's actually providing the equivalent of several pages of text as background to that response. So it tells ChatGPT, you're a large language model, you can't answer these kinds of questions, and so on. And when you engage in a conversation, it's taking your entire previous conversation and folding that back into the prompt, right? Which is how it seems to manage to sustain a conversation here. So it's hard to say to what extent this is a function of the wrapper that they built rather than the core capability of GPT. But perhaps we won't give ChatGPT the last word. I love this passage from Charles Dickens because it's from the novel Hard Times, where the wonderfully named Mr. Gradgrind is teaching a class, and this is during the industrialization of Northern England. Girl number 20, said Mr. Gradgrind, squarely pointing his square forefinger. I don't know that girl. Who is that girl? Sissy Jupe, sir, explained number 20, blushing, standing up and curtsying. Sissy's not a name, said Mr. Gradgrind. Don't call yourself Sissy, call yourself Cecilia. My father calls me Sissy, sir, returned the young girl in a trembling voice with another curtsy. Then he has no business to do it, said Mr. Gradgrind. Tell him he mustn't, Cecilia Jupe. Let me see, what is your father? He belongs to the horse riding, if you please, sir. Mr. Gradgrind frowned and waved off the objectionable calling with his hand. We don't want to know anything about that here. You mustn't tell us about that here. Your father breaks horses, doesn't he? If you please, sir, when they can get any to break, they do break horses in the ring, sir. You mustn't tell us about the ring here. Very well, then. Describe your father as a horse breaker. He doctors sick horses, I say. Oh, yes, sir. Very well, then. He is a veterinary surgeon, a farrier, and a horse breaker. Give me your definition of a horse. Sissy Jupe, thrown into the greatest alarm by this demand. Girl number 20, unable to define a horse, said Mr. Gradgrind, for the general behoof of all the little pitchers. Girl number 20, possessed of no facts in reference to one of the commonest of animals. Some boy's definition of horse. Bitzer, said Thomas Gradgrind, your definition of a horse. Quadruped, graminivorous, 40 teeth, namely 24 grinders, 4 eye teeth, and 12 incisive, sheds coat in the spring. In marshy countries, sheds hoofs too. Hoofs hard, but required to be shod with iron, age known by marks in mouth, thus, and much more, Bitzer. Now, girl number 20, said Mr. Gradgrind, you know what a horse is. And the point here is that when you change the target of your education from practical ability with horses to rattling off a bunch of meaningless facts, right? What gets valorized in the education system is precisely Bitzer's response and not Cecilia Jupe's response. And we run the danger here, I think, with models like ChatGPT, of sort of valorizing the kind of stuff that it puts out, particularly if it's going to become the norm for writing CNET news reports. And I've heard reports of people saying they love it because they can produce all this text for, their websites that they used to have to struggle over writing, right? We downgrade our expectations of what one should be able to do. So with that, I will end and